Let's dive into setting up your development environment. First, we'll look at choosing an IDE or text editor for TensorFlow development. You can use whichever you like. You might have something else that you're already using, or choosing something from the list that we have given describing here. Now, choosing an integrated development environment or IDE or text editor for TensorFlow development depends on personal preferences, your workflow, and the specific requirements of your project. Here are some popular options along with their features and considerations. The first one is PyCharm. The features of PyCharm is it's a powerful IDE for Python development with extensive support for TensorFlow projects. It offers features like code completion, syntax highlighting, debugging, version control integration, and built-in terminal support. The advantages of using PyCharm is PyCharm provides excellent support for scientific computing and machine learning workflows, including TensorFlow. Its intelligent code analysis and debugging tools can help streamline development and troubleshooting. Considerations: PyCharm may have a learning curve for beginners, and the professional version requires a paid license for full features. However, the free community edition offers sufficient functionality for TensorFlow development, and this is the one that I mostly use. Next one, Visual Studio Code or VS Code. This is one of the most coolest IDE out there. Supports pretty much everything, and this is what I use for my personal reasons. Because VS Code is a lightweight and customizable code editor with strong support for Python development and extensions. It offers features like IntelliSense debugging, version control integration, and a rich ecosystem of extensions for TensorFlow and machine learning. Some of the advantages are VS Code is highly customizable and has a large and active community of users and contributors. It's lightweight, fast, and can be tailored to suit individual preferences with various extensions available for TensorFlow development. While VS Code is feature-rich, some users might find it less integrated compared to full-fledged IDEs like PyCharm. However, its lightweight nature makes it a popular choice for developers looking for a balance between functionality and performance. And as developers, we've been using it for a long time, so why not keep using this? Next one, which is very popular among Python developers, is Jupyter Notebooks. Jupyter Notebooks provides an interactive environment for data exploration, visualization, and prototyping machine learning models. They support inline code execution, rich text formatting, and visualizations, making them ideal for experimenting with TensorFlow code. The advantages is that Jupyter Notebooks offer an intuitive interface for interactive development and experimentation with TensorFlow. They allow you to document your workflow, visualize results, and share insights with colleagues or collaborators. While Jupyter Notebooks are great for exploration and prototyping, they may not be suitable for large-scale software development or project management. They lack some features found in traditional IDEs such as robust debugging tools and version control integration. Next one is Spyder. Spyder is an open source IDE designed specifically for scientific computing and data analysis in Python. It provides features like Variable Explorer, Profiler, debugging, and integration with IPython consoles and Jupyter Notebooks. Advantages: Spyder offers a user-friendly interface tailored for scientific computational computing tasks, including TensorFlow development. It's well suited for data exploration, debugging, and interactive development with support for various scientific libraries. Spyder's feature set may be more focused on data analysis rather than full-fledged software development. While it's suitable for TensorFlow development, some users may prefer more extensive IDEs like PyCharm for larger projects. Others include Sublime Text, a lightweight and customizable text editor with support for Python and various plugins for TensorFlow development. Atom is a hackable text editor with support for Python and machine learning extensions for TensorFlow development. Emacs, a highly extensible text editor with Python support and packages for TensorFlow development. Some of the things that you want to consider is compatibility. Ensure that the chosen IDE or text editor is compatible with your operating system and meets the requirement for TensorFlow development. Next is workflow integration, which is choose an environment that aligns with your workflow and integrates well with other tools and services you use for development, such as version control systems and project management tools. That's why I use like VS Code for my personal projects and PyCharm for my work projects. Community support. Consider the size and activity of the community around the chosen IDE or text editor, as it can impact the availability of resources, tutorials, and support for TensorFlow development. Ultimately, the best IDE or text editor for TensorFlow development is one that suits your preferences, your workflow, and your project requirements. Experiment with different options to find the one that works best for you. Since a lot of you have requested for a video on how we can configure Jupyter Notebooks for TensorFlow experimentation, we're going to go over that here. Configuring Jupyter Notebooks for TensorFlow experimentation can enhance your workflow by providing an interactive environment for data exploration, visualization, and prototyping machine learning models. Here's how you can configure Jupyter Notebooks for TensorFlow experimentation. First, install Jupyter Notebooks. If you haven't already installed Jupyter Notebooks, you can install it using pip by saying pip install notebook. Create a virtual environment. Again, this is it is optional, but it's recommended to create a virtual environment for your TensorFlow project to manage dependencies cleanly. You can follow the steps outlined in the previous section to create and activate a virtual environment. Install TensorFlow in virtual environment. Make sure you have TensorFlow installed within your virtual environment. You can install it using pip, saying pip install TensorFlow. Ensure Jupyter Notebook kernel is available by saying ensure that you have the kernel installed for your virtual environment. To use it within Jupyter Notebooks, you can install the kernel using the following command: pip install ipy kernel and python -m ipy kernel install --user --name equal to -n --display name python -n. Replace that -n with the name of your virtual environment above. Next, launch your Jupyter Notebook. Navigate to your project directory or any desired location in your terminal where you want to create Jupyter Notebooks and run the following command: Jupyter Notebook. This will open a new tab in your web browser with the Jupyter Notebook interface. Create a new notebook by clicking on the new button and then select the kernel corresponding to your virtual environment. Example, myPython -env. This will create a new Jupyter Notebook using Python interpreter from your virtual environment. Next, import TensorFlow and start experimentation. In your Jupyter Notebook, you can now import TensorFlow and start experimenting with machine learning models, data pre-processing, visualization, and more. Here's an example. You can say import TensorFlow as TF. Next, check the version by saying print TensorFlow version is tf dot __ version __. This is your experimentation code here. You can add more if you want. Next, if you want to, once you're done with your work, you want to save and share your notebooks. After completing your experimentation, you can save your Jupyter Notebook and share them with your colleagues or collaborators. You can also export them to different formats like HTML or PDF for documentational purposes. That's one good thing about Jupyter Notebooks. Additional things that you can do is, one is extensions. Consider installing Jupyter Notebooks extensions to enhance your workflow further. Extensions like Jupyter _contrib _nb extensions provide additional functionalities for code formatting, table of contents, spell checking, and more. There's widgets which you can install. So Jupyter Notebooks support interactive widgets that allow you to create dynamic visualizations and control elements. You can explore libraries like IPY widgets for interactive experimentation and visualizations in your notebook. By configuring Jupyter Notebooks for TensorFlow experimentation, you can create a flexible and interactive environment for developing, prototyping, and exploring machine learning models with TensorFlow. Experimentation in Jupyter Notebooks enables rapid iteration and exploration of ideas, making it a valuable tool for data scientists and machine learning practitioners.